both start moving towards each other with same acceleration, a equal 10 meter per second square. Frequency of source is 2000 Hz. Find the frequency observed by detector at time t equal to 4 seconds. Speed of sound in air is 300 meter per second. So initially, this is a distance. So let me give a better diagram here. So this is the source. This is a detector. So initially what happened? They are separated by 1 kilometer. At t equal to 0. Both will start accelerating. I'll give 2 minutes time, try to analyze. So now observe by detector time t equal to 4 seconds. So somewhere the detector will be here. At t equal to 4 seconds, the detector will be here. And let this be the source. Where is the source? Let it be. So it is moving with a velocity, say vs1. The detector will be moving with a velocity, say VO. This is at t equal to 4 seconds. At t equal to 4 seconds, the wave will arrive here. When it should have been generated? So, somewhere at some instant of time, the source, when somewhere here, it would have been generated. And the detector will be somewhere here. Okay, now the wave will be generated. And the wave will propagate. And it will be detected at t equal to 4 seconds. See, if I hear the wave, if I hear the sound wave at 4 seconds means what does it mean? Prior to 4 seconds should have been generated. See, at 6 o'clock, if I say hello, then when I would have started speaking just before 6 o'clock, if suppose we are at a distance of 5 kilometers, the wave will propagate some time, need some time to propagate, no? Suppose you are at 5 kilometer distance. I say hello, immediately are you going to hear speed of the sound? Let's say they get 400 meter per second. So you are at distance of 5 kilometers or say 500 meter per second speed of sound. So minimum time, how much needed? 10 seconds. If you are going to hear, suppose at 6 o'clock, if I say hello, okay, this one, and the speed of sound is how much? 500 meter per second. What is the distance? X equal to 5 kilometers. Tell me, like, when I would have said hello, at 6 o'clock, I said hello. When you are going to hear it? Exactly after 10 seconds. After 10 seconds, so 6, 0, 0. I think this will be your timings, no? Will be like this. No, you say at 10, at 6:10, at 6 o'clock, 10 seconds. If you have heard hello, then when I would have said prior to that, the same thing. At 4 seconds, if I hear the sound means when it should be generated, prior to that. So what is this distance? Distance moved by the source. There's a distance moved by the detector. Anybody, can you say what is this distance? What is this distance? Distance by whom? By the wave. Distance propagated by the wave. No, because the signal is generated, it has to propagate distance, some distance to reach the detector. That's what this happens here. Okay, what is our first of all, let's come to the Doppler effect. Well, let's get into Doppler. What is the Doppler effect formula? Then we'll come to know what is unknown thing to be determined. What is the Doppler effect formula? Doppler effect formula says that V, detector is moving towards observer, V plus VO, F dash it is, V plus VO, F, V minus Vs. What are VO and Vs? Speed of observer when sound is heard. What is Vs? Speed of source when sound is generated. No, that is what Doppler effect. In Doppler effect, what are VO, Vs? Vs is the speed of sound when signal is generated. VO is the speed of the detector when signal is detected. Do we know these things? As we know VO. What is VO? 80. So I'll write 80 dash, or this is A into 4. So we know acceleration 10. So 10 into 4, 40 meter per second. What is the only unknown thing? The Vs is unknown. What is Vs? Vs should be equal to A into T. So this is 10T. The T is unknown thing. How to find out that T? Anybody? Yeah, looking at the diagram. Anybody? Can you answer? Yeah, diagram. No, look at the diagram and analyze how to find out that time T. I have this 1 kilometer. So what is this 1 kilometer? You can write it as xs plus xw plus xd. That's all. Now, what is xs? So let's do one thing. That 1 kilometer. That's why this diagram is very important. XO. This is XO, no detector. Yeah. No, no. What is one? This is 1000. This is A T square by 2. What is XW? Distance propagated by, by the wave. Distance propagated by the wave. What is the speed of the sound V into for what time the wave will propagate? 4 minus T. What about X naught? This will be A into 4 square by 2. What is the only unknown thing? The T is unknown thing. Quadratic equation. Solving this will get expression for T. That value of T I'm going to substitute here. That then I'll get Vs. Then I'll get apparent frequency. Distance, propagation distance of the sound wave. I think this is the concept. So I think drawing diagrams, let's leave it okay, very good, no? Like this, what you can put it like, you can go to kinematics. A source is vertically projected, detector is dropped, then acceleration due to gravity will come. That this acceleration is what I brought it, no? Then he may ask you some similar question of like this. Detector is projected vertically up and the source is dropped vertically down from rest. detector is should be projected. Then detector is going to describe the retarding motion. Source water pen will be describing the excited motion. Then the same thing, the Doppler effect can be asked there also in projectile motion. And I'll take the next one here.